Welcome friends. In today's lecture we are going to discuss coordinate measuring machine and NC system. If time permits we will also discuss the CNC system. So let us start with the coordinate measuring machine. What is CMM? CMM is a device for measuring the physical geometrical characteristics of an object. Let us say there is some physical object and we are doing some reverse engineering. General purpose for CMM is reverse engineering, as well as it is also used in some aeronautical and some industrial purposes also. So very first we will discuss the any object. Let us say it is one product which is already in market and we have to copy it. Generally what happens when we produce any product, we engineers have some idea in our mind, then we develop some theoretical values and diagrams, then drawing, then finally we actually do the production depending on the idea. But in reverse engineering we take any product. Let us say this is one power bank, then I want to manufacture such shapes, but I don't have any idea and values, any drawing for the same. Then what we will do, I will use a coordinate measuring machine, and one probe will be like this. It may be optical or some mechanical probe. Then it will move on this surface of any object. Let us say this is a power bank. Then it will take values, coordinate values, and generate a mathematical form of the physical object, and from that we can again create a prototype, drawing, 3D model, and we can also analyze it in any software like ANSYS, and finally we will actually produce and do a mass production. So CMM machine may be manually controlled by an operator or it may be computer controlled. That means it is a flexible machine. Measurements are defined by probe attached to the third measurements are defined by probe attached. Probe can be, I have already told you, the laser or white light or mechanical or optical, amongst others also. So the third moving axis of the machine, that means let us say X, Y, Z, 3 axis. So the machine which takes reading in 6 degrees of freedom and displays these readings in mathematical forms is known as coordinate measuring machine. 6 degrees of freedom it have. I will also show, if you may have seen a bridge type structure or different structures are there. Let us say I will draw here one schematic. This is, let us say, a coordinate measuring machine. Look at the screen. This is straight line, let us say, and here somewhere will be our probe. I will use another color for the same. Let us say this is our probe. Okay. Now this probe is attached here on this bridge like structure. Now it have such type of motion on the bridge. Okay, like this. Also it can this complete horizontal beam can also move on this vertical surface on these two let us say columns, as well as this assembly can also move in the Z direction. Let us say this is, X, Y, Z. In this way, it can have 6 degrees of freedom to and fro motions. So moving to the next discussion, that is working principle of the CMM. According to measuring machine, the coordinate measuring machine is also a device used in manufacturing and assembly process to test a part or assembly against the design intent. You know that if there is a large, let us say, car, then you have to test each part, and if you are going to design or produce a, let us say, CNC program, then there will be part programming and all, because complete car cannot be programmed in one, what I can say, instruction or one block. We will see what are these blocks and all in CNC in the next lecture or at the last of this lecture itself. By precisely recording the X, Y, and Z coordinates of the target, points are generated which can be analyzed by regression algorithms for the construction of features. These X, Y, Z coordinates can be analyzed via regression or algorithms for construction of features. Any feature, let us say it is a triangular, rectangular, or any irregular feature also. These points are collected by using a probe that is positioned manually by an operator or automatically via direct computer control. I have shown you the one example. It is not necessary the bridge structure will be there everywhere. Different types of designs are also available in market for the CMM. The main parts of the CMM are air bearing, scales and encoders, probing system, that means probe like structure. It may be a stylus like or optical scanner or anything. Servo motors. These motors have different speeds and which can be controlled by computer. Such type motor is used. It is not our regular motor. Control system, then joystick or controlling the, let us say, any probe or any movable part. Then software, which will be useful for controlling this CMM. The advantages are flexibility. What are the advantages of this CMM? It is flexible. That means it can be used either manually or with the help of any robot, automated robot, or any system, computer as well. Reduced setup time. It has very less time for setup. You need not to worry about setting tools and all. In single setup, once you set up, it will work for further operations automatically. Accuracy will be more, but it is not possible that 100 and let us say 100%. Always there will be some errors, very minute, negligible. Reduce operator influence. That means if it is a manual system, then there may be some influence of any person. It may have any habit which may create particular error. So reduce operator influence. There is very less operator influence and improved productivity. Productivity will be increased due to automation. Applications, as I have already discussed, that very popular application is the reverse engineering, and apart from reverse engineering, it is also used in medical technology, automobile engineering, aerospace engineering. These are some mass production applications in industry, with aerospace, automobile and medical. So that was all about this CMM. Now we will start the numerical control system, NC system. It consists of three basic components. One is program of instruction. It is also called as block. The detailed step-by-step directions which tell the machine to do something. Let's say whatever it have to do, that step-by-step directions are known as program. Those programs are written on the tape or plastic-like paper or plastic tape. You may have seen audio cassettes which were used in earlier days. Here you can see these instructions are given by using punch tape. It is a punch. Here you can see dot 1, 2, 3, 3 dots, 4 dots. The number of dots are there. That means punching is there on this tape which is of paper or plastic. And similarly, like our cassette or audio cassette, the one probe or one system will be there for reading. This tape will be moving in a particular direction. So these dots will be read by this system and the particular operation will be carried out. Now see what this dot, how many dots are there and how many tracks are there. Such 8 tracks will be there on tape. 1 to 4 tracks are numerical, whereas the 5th track is a parity check. That means if there is any error, then it will be detected. This 5th track is used for error detection. 6th and 7th track are the alphabets. Let us say if T6 is given. T stands for the tool. This T alphabet on 6th or 7th, it will indicate the tool. There may be different or multiple tools that say T6, T7, in which tool machine has to select. It will tell this 6th and 7th track. And 8 is the end of block. Block means instruction. This complete block or set of instruction has to be stopped. It is given by this 8th number track. Now, second component NC system consists the second element which is machine control unit. It is like our CPU. Here you can see once we get input from the tape, it will process and will give a output. Data processing unit and control loop unit. These are considered under machine control unit. This data process unit will consist of tape reader. Here let us say it is a data process unit. And in control loop unit, it consists of position control, velocity control units, as well as spindle on-off units, etc. These things will be there. And third is the machine tool, which tool a machine should use, and it is, let us say, a turning operation or facing operation. Then lead tool we will use. So which actually perform the action or the operation, that machine tool. This is the third component of the NC system. Now we will study the CNC. The only difference is that actually the procedure or the workflow is very similar. Just the difference is that in CNC programming there will be a digital program, right? This is CNC system, and that digital program will be written in G codes and M codes. Some other instructions also be given, but basically it will be in G code and M code. How these G codes preparatory functions work, some examples are given here. Look at here. G00 means rapid traverse. That means if there is coordinate system and our work, let us say, has been completed for one operation, then if you want to move for another operation, then we will give this code G00 for rapid traverse. Then G01 is a linear interpolation, means if there is cutting operation in the straight line, let us say like this, then this G01 command will be used, G code will be used. G02 and G03 are for the circular interpolation. Let us say this is such type of feature or cutting we want to perform. Then these G02 and G03 will be used. Whether it is in clockwise or anti-clockwise, it depends on the operation, and for that 02 or 03 will be different. G04 is a dwell time, idle time. That means at that time tool should not do or should not perform any operation. G17 is, that means it tells tool should perform or work in the XY plane. Similarly, look at here, if it is asked, generally it will not be asked, but G7 after G17, G18 is not YZ plane, it is a ZX plane, and after XY plane it is ZX plane, and after ZX plane G19 is YZ plane. G40 is the cutter radius compensation stop. Then what this G41, 42 will be used, how they will be useful, we will see in the example. Let us just look at here what is the meaning of these codes. Cutter radius compensation. If left side cutter radius compensation is there, if, let us say this is our workpiece. Okay, this is rectangular considered, and we are moving in this direction. Then our, let us say this is the cutting tool, any circular shape. It may be any type of rotating tool like drilling and all like that, or milling cutter. Then this is the center. Then if we will give instruction for, let us say this is a 0 coordinate, this is 0 0, x 0, 1, y coordinate is also 0, let us say. Then we have to compensate that the tool dimensions also, because if we will start from 0 0, the cutting tool diameter will not be considered, and we will get a cut of dimensions of a milling cutter, and it will be wrong. So we have to give compensation. We will see it in an example. G28 is the home position. After doing all the operation, if we want to return the tool to its original position, then G28 is used. G70 is dimension. If dimensions given are in inch, then we will use G70. If dimensions are given in metric, that means meter or millimeter, then we should use G71. After that, G90 for absolute coordinate system. What is absolute and incremental, we will also see with the help of figure at the last of this lecture, very last 2 slides. G92 is preset, G94 is feed rate if it is in mm per minute, and if it is mm per revolution, then there should be G95 code written in the program. Now some miscellaneous functions are also used in the program for CNC. First, M00 represents the program stop. It will be at this end of the program. M01 is optional stop means in between if you want to stop but not complete the, but we have not, let us say, completed our entire procedure. In the next figure you can see here, let us say I have done, or machine have done this much cutting operation, but due to some reason uh, the operator or the supervisor has to go somewhere, then what he will use M01 optional stop code. So after returning, the machine will start from here itself. It will not start from the beginning. For this, M01 is used. M02 end of program complete. If operation is done, then M02 will be used. M03 and M04 are for the spindle start operations. Whether we want to start in clockwise or anti-clockwise, that is the difference only. The M03 and M04. M05 spindle stop, M06 tool change, M07, M08 are the coolant on. Why these two are given? There may be multiple coolants. Let us say multiple coolant types are there. Coolant 1, coolant 2. Then we can use these two. M09 is coolant off. If you want to stop the coolant flow. Now part programming. As I have told you, why we call it as part? Because we will not program for entire assembly. Let's say car is there. We will first of all do a programming for any part. Let us say bolt. Then we will manufacture the bolt. So this programming is called part programming. Let us say our one sheet is there, rectangular. For this we are writing a part program. Then how will it be? It will be like this. N01 means block 1 or instruction 1. This complete block or this complete instruction for this, and the starting is given like N01. Here N02, N02 like this. No doubt if you don't want to do this numbering or instruction separately, if you want to write all the instruction in one line only or in one block, you can write it also. But for understanding, for our purpose, machine will perform it properly. But whenever if you want to change program or any manipulation you want to do, then it will be helpful for understanding. So these different instructions are given. G90 is absolute coordinate system. G17 work in XY plane. We are giving instruction to the machine or tool. G71 dimension should be in mm. G95 feed rate in mm per revolution, right? Not mm per minute. T6 use tool number 6. Then this feed rate is F2 stands for 2 mm per revolution. Okay. F2. F3, if there will be a F3, then 3 mm per revolution will be the feed rate. S20 is the spindle speed should be 20 rpm. We have given only the speed. Then when to start the spindle, we will give again another instruction or another code for it. And E0B is the end of this block, this complete block, or this instruction number 1. Similarly, now in the next block, what we will see, this is the G00. What G00 stands for, we have seen here. If you have any doubt, you need not to remember all these things. This will not be asked in exam, just for your understanding. Now, this means rapid traverse. After doing particular one operation or setting, if we want our tool to rapidly traverse to this position, let us say X0, Y0, Z3. This is, then the what I can say, tool will move to this position. Z3 means, let us say this is our component. We have already drawn. This is here 0, 0 and Z component is Z coordinate is 3. That means somewhat away from this 0 0. If we are taking that the towards me, let us say, this is the Z axis. Then screen is the XY plane. Then 3 mm from the screen there will be a Z point, Z coordinate equal to 3. There the tool will go rapidly and stop there. Similarly, we will give further instruction M03. Here we have given instruction to start the spindle. G01 linear cutting, that means linear interpolation should be done. Z3, then tool should go to the -3 position. That means previously it was somewhat away from the screen. Now we want to travel the tool to the 0, 0, 0 position, right? Similarly, the complete program will be written. Here you can see your homework is that you have to understand and write all the instructions in alphabetical manner, or in, what can I say, like this. Here I have given all the instructions. You have to write this instruction here itself and completely understand the program, what exactly it will do. Now the last point is the listing of coordinate, whether it is an absolute coordinate system or incremental. Absolute is very similar as we generally use in our daily life. The absolute coordinate, you know that this is point A is 2, 2, that is x coordinate is 2, y coordinate is again 2, B is 5, 3 as it is. But if previously our tool is here and if you want to move your tool here, then in incremental coordinate system you should write 2 plus how much this distance is, 3, I think 1 2 3, 2 plus 3 will become equal to 5. So 3 comma here in y direction 1 in the here from A to B, 3 comma 1 here you can see, right? This is the incremental system. Again for B, if you want from B you want to see, go to the C, then -1 you have to travel and again plus 2. Here you can see C should be -1 comma 2. Similarly for point D, this is the incremental system, coordinate system. This was all about the NC programming. Now we will see the why we were using those compensation. Let us say this is the circular tool and I have given the coordinate 0, 0. If you will cut like this manner, here you can see our cutting will be the cut portion finally which we are getting will be 90 by 90 instead of 100 by 100, because this cutter itself has some diameter which is, let us say, 10 mm. But to avoid this, what we will use, compensation. Let us say this is a tool, its diameter is like this. So how to use this compensation? Here you can see the trajectory will be like this. This trajectory can be asked in gate. -5, -, such type of trajectory we should give instead of 0, 0, -5, -5. Then this 105, -5, right? Similarly, for all the points, such trajectory should be given. But the direction of movement or travel of the tool will change our code. If we are looking like this, we always face towards the travel direction of tool for giving the instruction. If this is moving in this direction. That means we have to use left hand compensation G41. If this is traveling in the downward direction, if we will stand here and look in this direction towards the travel direction of the tool, then this should be right hand compensation should be there and code will be G42. Now, so our new trajectory will be like this. Path will be same, but the trajectory will be different. If let us say this is our tool, it is moving in this direction, so we are using left hand compensation. So we will get -5, -5, then second -5, 105. Like this, all these points we will get. This was the meaning of compensation code, cutter compensation codes. So we have discussed completely NC, CNC system and CMM also. If you have any doubt, you can ask in comment box. Thank you for watching, and don't forget to like, subscribe and share our channel for getting such useful videos in future also. It will help us to motivate. Thank you once again. Signing off for the day.